Hello everyone and welcome once again to MJ's Maths and Stats. That's MJ Magic Studio to you. I am your host, your host, and as usual in the ghost mode, Mohit Jain. So welcome to part 2 of Target TCS Digital. The process, the pattern we have already discussed in our first part. Link is there in the description below. Please go through it. So without wasting any time, let's start now. I discussed in part 1 2 few questions might be of theta type format like the one which is on the screen where you need to type in the answer in the box given. So there won't be any option. Theta is type in the answer, box would be given, you need to type in the answer with your keyboard. Give it a try. 4 students A, B, C and D form a team to take a part in 4-leg relay competition. That means they would be running one after another. One will complete suppose 100 meter, then another one will run for 100 meter, another one will run for 100 meter, and then again the last one will run for 100 meter. It may be like 400 meter race. D and B cannot run the first and the last leg of the relay respectively. That means in the first leg D is not running, and in the fourth part B is not running. Okay. Then how many different ways are there in which they can be arranged to run the relay? Now suppose if there is no condition, if this condition is not given, then it is a very simple question. 4 people can be arranged in factorial 4 ways. That is, there would be 24 ways in which this relay race can be arranged. But D should not start the race. D should not start the relay. Now we need to find out that if D starts, then in how many ways we can have the race. That means in how many ways we can arrange these 4 objects given that it is starting with D. If it starts with D, the 3 places with the 3 left over A, B, C can be arranged in factorial 3, that is 6 ways. That means there are 6 arrangements where D is starting the relay. Now in how many of the relay B is ending the game? Obviously again 3 people left, 3 places left. This would be arranged in factorial 3, that is 6 ways. So there are 6 arrangements where B is running the last leg. Now there would be also few arrangements where D is starting and B is ending, isn't it? Now 2 of them is left, that is A and C. They can arrange themselves in factorial 2, that is 2 ways. So these 2 ways are common in these 2. So final answer would be how many different ways they can be arranged with the given restriction. Total cases minus starting with D, minus ending with B, add starting with D and ending with B, because these 2 cases we have taken it twice in both these 2. So 24 plus 2, 26, minus 12 is 14. There would be 14 ways in which this 4-leg relay competition can be held. One more theta based question from arrangements. Give it a try. A 5-digit number is to be written using 1, 2, 3, 4, 5. We have got only 5 digits. Using exactly once. That means repetition is not allowed. That means we will use formula NPN, factorial n, because there are n objects, those are 5 objects and 5-digit number is required. So if there is no restriction, you would get factorial 5, that is 120 numbers of 5 digits. But they are saying that such that number is divisible by 4. Now a 5-digit number or any digit number is divisible by 4 when the last 2 digits are multiple of 4. If last 2 digits are divisible by 4, the entire number is divisible by 4. So let's make a combination with these digits and see how many combinations of numbers we can have of 2 digits which are multiple of 4. So if we start with 1, we can have 12, 13, 14, 15 out, with 2, 21, 23, 24, 25 out. With 3 is 32. With 4 is 41, 42, 45, nothing. With 5 is 52. Okay, so with these 5 digits, we have got only 4 combinations, which can be put into these 2 places. Clear? So out of these 4, only 1 pair will be sated at these 2 places, and the remaining 3 would occupy these 3 places. So 3 objects can occupy these 3 places in factorial 3 ways, that is 6. And out of these 4, we need to put only 1 pair here in 4p1 ways, that is 4. So final answer is 6 into 4, 24. We will have 24 5-digit numbers with the digits 1, 2, 3, 4, 5, where digits are used exactly once, which are divisible by 4. So in the box, we will write 24 and move on. Give this question a try. It is actually not from permutation combination, but you might be using some logic of arithmetic progression and set theory. Try it. How many 4-digit numbers are there? Okay, 4-digit number starts from 1000 to 9999. So how many 4-digit numbers are there which are divisible by 3 or 5, but not by both 3 and 5? Suppose these are the number which are divisible by 3. These are the number which are divisible by 5. And this portion gives us the number which are divisible by both 3 and 5. Both 3 and 5 means 3 into 5. 3 and 5 both are coprimes. So 3 into 5 is 15. These are the number which are divisible by 15. We are looking out for these numbers and these numbers. Simple. Okay. Now, for number which are divisible by 3, the smallest of the number in this range would be 999 plus 3, 1002. And the largest of the number in this range would be 9999. And all these numbers in this series forms an AP series, isn't it? Where first term is 1002, last term is 9999, common difference is 3. So how many numbers are there in this range is given by a simple formula, that is let L minus A by D plus 1. How we have got this formula? By using the last term formula. Last term of any AP series is given by A plus N minus 1 into D. So if you will solve this, it will be L minus A divided by D plus 1 will be equals to N. That's it. It's not a miracle formula. It's just a formula we know, we have derived. So in this case, number of numbers which are divisible by 3 would be 9999 minus 1002. We'll divide this by 3 and add 1, and here you will get 2999 plus 1, that means 3000. So there are 3000 numbers which are divisible by 3 in this range. Similarly, for divisible by 5, our last number would be 9995 and the first number would be 1000. Divide this by 5 and add 1. L minus A by D plus 1. Here we'll get 1799 plus 1, that is 1800. So this is 1800. Now we are looking out for how many are divisible by 15. First number which will be divisible by 15 would be 1005 and the last number would be 9990. So minus 1005 divided by 15, add 1. It will be 599 plus 1, that is 600. So this portion is 600. So how much is this portion? 3000 minus 600, that is 2400. And this is 1800 minus 600, that is 1200. So our answer is, how many numbers are there which are divisible by 3 or 4? That means whole, but not by 3 and 5. This element we are subtracting. So we will just add this 2400 and 1200. So final answer would be 2400 plus 1200, that is 3600, to be put in the box. Okay, next one from probability. Give it a try. Okay, let's see what we have here. A bag contains few black balls, red balls and white balls. Total number of balls are z plus z plus z, 3z plus 15. Okay. The probability of getting a black ball is 1 by 4. So total number of black ball is z plus 2. So probability of getting one black ball is z plus 2 divided by total number of balls, 3z plus 15. That is given as 1 by 4. We just need to solve this, and first we need to find the value of z. So we have 4z plus 8 equals 3z plus 15. So z is equals to 15 minus 8, that is 7. So 7 plus 2, 9. We have got 9 black balls. Red are 7 plus 5, 12. And white are 7 plus 8, 15. So 29, 30, 36. 7 into 3, 21. We have got 36 balls. Done. First part. Now the question, what is the probability of getting 3 balls of different color when 3 balls are drawn? Since nothing is given about drawing, we'll always consider that drawing is without replacement. And whenever it is without replacement, we use the concept of combination. So to get all the 3 balls of different colors, it should be 9c1 into 12c1 into 15c1 divided by 36c3. Favorable cases divided by total number of cases. 9c1 is 9 into 12 into 15. 36c3 factorial 3 is 6. And it would be 36 into 35 into 34. You know that nc3 is nothing but n into n minus 1 into n minus 2 by 6. Okay, now we need to solve this. 6 goes 6 2 times. Then we have 5, 3, 5, 7. And this is 2, 17. So 9 into 3 is 27. And 17 into 7 is 119. So final answer is 27 by 119. That is in option C. Direct take on combination, give it a try. As said in part 2, we are featuring more of questions from permutation, combination and probability. Number of ways of choosing x plus 8 balls out of 36 balls. That is 36c x plus 8. Choosing means combination technique. Is equal to choosing x balls out of 36 balls. So this is equals to 36cx. Now we know that if nca is equals to ncb, then we have two conditions. Either a is equals to b or a plus b is equals to n. Now here we can see that x plus 8 cannot be equals to x. That means in this case a x plus 8 plus bx, this should be equals to 36. 2x is 36 minus 8, 28. X is equals to 14. Now find the number of ways of choosing x plus 5 balls. 14 plus 5, that is 19 balls out of 25. They are asking us to find the value of 25c19. Now we have got one more concept in combination, that NCR is same as NCN minus R. So 25c19 will give the same value as 25c. 25 minus 19 is 6. Clear? So this would be 25 into 24 into 23. Write this 6 times. 22 into 21 into 20. 1, 2, 3, 4, 5, 6 divided by factorial 6. That is 720. Okay, we can use on-screen calculator. So we are 25 into 24 into 23 into 22 into 21 into 20. This divided by 720. This gives 177100. 177100. That is in option C. For those who are attending the session for the first time, on-screen calculator is there in TCS Digital. Make use of it wherever, whenever possible. Let's move on to the next one. A question from probability, but it demands basic concepts of arrangements. Let's do it. Classical take. The probability that in a random arrangement of the letters of the word probability, the vowels come together. We know that probability is finding out the total cases first. Total cases. How many objects do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that would be arranged in factorial 11 by. Now, why by? We need to divide by that number where any object is repeating itself. Like we can see that B is occurring twice, I is also occurring twice. So we will divide this by factorial 2 and factorial 2 to nullify the same images concept. When clear? So total cases would be factorial 11 by factorial 2 factorial 2. This is first thing. Now here they are saying that vowels come together. That means to find the favorable cases, we need to use the concept of grouping. Suppose we have got n objects, out of which g objects need to be always kept together. Then in how many ways we can arrange is simply given by factorial n minus g plus 1 into factorial g. That's it. This is the group effect formula. If there are n objects and different objects need to be arranged such that g objects are always kept together, then the number of arrangement is given by factorial n minus g plus 1 into factorial g. Now how many vowels are there? O, A, I. We have got 4 vowels. So favorable number of cases would be factorial 11 minus 4 plus 1 into factorial 4 and divided by factorial 2 for 2 B's and 2 I's. Now probability is given by favorable cases divided by total number of cases. We can see that here denominator is same, so we can avoid it. So 11 plus 1, 12 minus 4 is 8. Factorial 8 into 24 divided by factorial 11 can be written as 11 into 10 into 9 into factorial 8. Gone. 2, 12, 2, 5, 3, 3, 3, 4. So we have 4 upon 15 into 11 is 165. We can see the calculator value. So 4 by 165 is 0.0242. It is 0.0242, which features in option D. A popular take from probability and independent events and regularly asked, so give it a try. So 3 persons, Pradhu, Qureshi and Rajesh independently try to hit a target. These are independent events. Let's see, it is P, Q and R. Okay. If the probabilities of them hitting the target is given, then the probability that the target is hit by Qureshi or Rajesh, this area, Qureshi or Rajesh, but not Pradhu. That means we need to take out this portion. We are looking out for only this portion. So it would be something like Q minus P intersection Q, Q minus P intersection Q. We have got this area, and this particular area would be if I take the complete R minus, if I take out this area, P intersection Q, this area is P intersection R, minus Q intersection R plus PQR. We need to add this. So it is simply Q plus R minus P intersection R minus P intersection Q minus Q intersection R plus PQR. And since all of these are independent events, we can use the concept of independent event. Probability of A, B, if A and B are independent event, is given by PA into PB. So let's just do this. Probability of Q is 2 by 3 plus R is 5 by 12 minus P into R, 1 by 4 into 5 by 12 minus P into Q, 1 by 4 into 2 by 3 minus Q into R, 2 by 3 into 5 by 12 plus PQR plus 1 by 4 into 2 by 3 into 5 into 12. Okay. So into 4, 8 plus 13 by 12 minus, let me keep it like this, into 3, 15 by 144 minus 12, 24 by 144 minus 4, 40 by 144 plus 10 by 144. 30, 54 and 15, 69. 13 into 12 is 130 and 26, 156. 156 minus 69 by 144. So 7, 16 minus 9 and 14, 87 by 144. 329 by 3 is 4 and 8. So finally we are getting 29 by 48. Option D is the answer. Taking break from PC Prob, let's drop down to algebra once again and solve few questions from it. A question on the screen, try. So PQ are real and rational, then what will be the quadratic equation whose one of the root is P plus Q root 2? Now we know that if one of the root is P plus Q root 2, another root has to be P minus Q root 2. If alpha is P plus Q root 2, then beta is P minus Q root 2. We need sum of the roots. Sum of the roots is, if you add up, you will get 2P. We need product of the roots. Product of the root is A plus B into A minus B, that is A square minus B square. A square minus 2Q square. And if we have sum and product, then the required quadratic equation is x square minus sum into x plus product is equals to 0. So the required quadratic equation is x square minus 2px plus p square minus 2q square equals to 0. That features in x square minus 2px plus p square, that features in option A. Okay, let's see. By solving the inequality, the range of x is this. Then the values of a and b satisfy which of the following? We have got minus 20 less than 12x plus 4 less than equals to 64. So now first we will do minus 4 on all the three sides. So minus 24 is less than 12x less than equals to 64 minus 4 is 60. Now divide this by 12. Minus 2 is less than x less than equals to 5. That means value of a is minus 2 and value of B is 5. And now you need to just put in the options and check which option fits in. So if I try in B, A into B is minus 10, minus 5A is plus 10, plus 2B is plus 10, and minus 10, this will give me 0. Okay, it fits in option B. Another one from quadratic, give it a try. So let's see what we have here. A, B are roots of this quadratic equation. That means sum of roots A plus B is equals to minus B by A, that is minus K by 1, that is minus K. And product of roots A into B is C by A, that is 2 by 1, and that is 2. And A minus B is equals to 1. So you can say A minus B whole square is equals to A plus B whole square minus 4AB. Simple identity. A minus B is 1, 1 square is 1. A plus B is minus K, that is K square, minus 4AB. 4AB, AB is 2, that is 8. Therefore K square is 1 plus 8, that is 9. So K is root 9, that is plus minus 3. And that is in option D. Let's do a few questions from geometry and mensuration which are regularly asked in TCS Digital. Give this a try. If the area and the diagonal of a rectangular field, area of rectangular field is length into breadth, that is 420 meter square, and diagonal is given by root over L square plus B square for a rectangular field, that is given as 29. So L square plus B square is 29 square, that is equals to 841. What is the length of the rectangle? Length is basically supposed to be the longer side. Normally the basic assumption is length is greater than breadth whenever we are talking about rectangles. Now L plus B whole square is L square plus B square 841 plus 2 into LB, that is 840, which will be 1681. So L plus B comes out to be root over 1681, which is 41 square. So L plus B is 41. Now we can see L into B is 420, L plus B is 41. Either we can crack it out at 21 and 20. We can see that 21 into 20 is 420. So L is 21. Or else solve L plus B equals to 41 and LB equals to 420. Frame a quadratic equation and solve it. Or simply if it can be broken up and you can like see, then directly you can write. Please write answer 21 and not 20 because the basic assumption is length is greater than breadth. One more from three-dimensional mensuration. You know the drill. A right circular cone of height 15 centimeter and radius r, height 15, is melted. That means volume need to be considered. Volume of cone is 1 by 3 pi r square h, height is 15. Okay, and recasted into a sphere. Okay, a sphere, something like this, joint of radius 15 centimeter. Here radius is 15 centimeter. So volume of sphere is 4 by 3 pi r cube, radius is 15. Now these two volumes should be same. 1 by 3 pi r square into 15 equals 4 by 3 pi 15 cube. Then what is the radius of the cone? We are looking out for this value of r smaller. Pi cancel, 3 cancel, 15 gone with this 2. So r square is 2 square into 15 square. Therefore r is 2 into 15. That is 30. Radius of the cone is 30 centimeter, which need to be put in the box. In the box, we normally don't write the units. You are only supposed to type in 30 in the box given. Two-dimensional triangles and rhombus taken together. A very nice concept questions. Give it a try. Okay, let's see what we have. A rhombus with one diagonal 18 centimeter has area equal to that of triangle with sides 15, 15 and 18 centimeter. What is the length of the other diagonal of the rhombus obviously? For a rhombus, area of rhombus is given by half into d1 into d2. That is area of rhombus. And this is equals to area of a triangle whose two sides are 15, 15 and the third side is 18. That means it is an isosceles triangle. We can use the formula directly. If we have an isosceles triangle where the common sides are b and the uncommon side or the unequal side is 2a, then area of this isosceles triangle is given by a into root over b square minus a square. We can use this formula directly. If you can remember, that would be easy. So here value of a, it is 18, that means a is 9 into root over b is 15, 15 is square minus a is 9, 9 is square. 225 minus 81 is 144, 145 for root is 12. So area is 9 into 12 and one of the diagonal is 18. So now if we compare, half into 18 into d2 equals 9 into 12. 2, 9, 9 gone. d2 is 12. Length of the other diagonal is 12 centimeter. We will type in 12 in the classical take on cuboids or parallelepiped. You know the drill. Give it a try. Let's see what we have. The height of cuboid is 5/4 time of its length and the breadth is 1/3 time of its length. Okay, so we have height, length and breadth. Ratio of height and length is height by length is 5/4 and ratio of L by B is 3/1, isn't it? B is 1/3 of L. B is 1/3 of L. L is to B is 3:1. So the combined ratio would be 15:12:4. Now if volume of cuboid is 720 meter cube, that means volume is H into L into B. That means 15 into 12 into 4 into the variable xxx. Suppose that is a cube. That is equals to 720. So 1260, 15, 460 gone. That means a cube is equals to 1. 48 into 40. Correct. That means value of a is 1. Height is 15. Length is 12 and breadth is 4. So what is the sum of height, breadth and length? We just need to add up. 27 plus 4 is 31. In the box given we will type in 31. Last one from this session. Give it a proper try and we'll send you the PDF. Don't worry. Give it a try. Find the ratio of area of a regular hexagon. Regular hexagon means all 6 sides are equal. So if sides of this regular hexagon is A, then area of regular hexagon is given by 6 times the area of equilateral triangle formed with the sides AAA. Area of equilateral triangle is root 3/4 side is square. So that comes to 232. 3 root 3/2 a square. Find the ratio of area of regular hexagon, which is 3 root 3 by 2 a square, and the area of a circle passing through the vertices of hexagon. There is a circle which is touching all the 6 vertices of hexagon. Then we can see that radius of this circle is nothing but the side of the hexagon. The diameter is 2a. Radius of the circle is a. So the circle which is circumscribing this regular hexagon, its radius is equals to a. So area of this circle is pi r square, that is pi a square. We are supposed to find this ratio. 3 root 3 a square by 2 is to pi a square. A square cancel. It is 3 root 3 is to 2 pi, which is in option B. Good, keep on practicing. I'll come back. Don't worry. Thank you everyone for participating.